Hi, we carry on looking at the 2025 mock trial paper, and we stopped at question 113 in the last video. We now move on to question 1.14, which is an exponential equation reading 3 to the power x plus 3 to the power 4 minus x is equal to 18. So the first thing I'm going to do here is split up the second term. And we're going to write that as 3 to the power 4 times 3 to the power minus x, which is equal to 18. And in the next step, we know 3 to the power 4 is 81, and the exponent is negative, so we take it to the denominator, and it becomes 3 to the power x, which is equal to 18. I'm going to use a simple technique, which is the K method, and let 3 to the power x equal to k. Now, wherever I got 3 to the power x, I'm going to replace it with k plus 81 over k is equal to 18. And then we're going to find an LCD. And in this question, the LCD is k. So if we multiply the first term by k, we get k squared. If we multiply the second term by k, the k will cancel off. We're left with the 81. And we multiply our third term by k, we're going to get 18k. So I use an LCD was k. Now I'm going to bring it all to the left to form a beautiful trinomial. K squared minus 8k plus 81 is equal to 0. We're then going to factorize that, and the factors would be k minus 9 into k minus 9 is equal to 0. And we end up with k to be equal to 9. But remember, we let 3 to the power x equal to k. So we're going to bring that back in and replace k with 3 to the power x is equal to 9. Thereby 3 to the power x is equal to 3 squared. 9 can be written as 3 squared. Our bases are the same. Therefore, x would be equal to 2. Today we have a 4-mark question. The next question is a little bit more challenging, 1.2, which says show that the roots of x plus 3 into x plus n is equal to 4k squared. They are real for all real values of m, n, and k. Well, this is actually a nature of roots question. And in a nature of roots question, if you remember your nature of roots, we know for us to get roots that are according to the question, just want to underline that, for us to get roots that are real, it means that delta has to be greater and equal to 0. And remember, delta is actually b squared minus 4ac has to be greater and equal to 0. So what we're going to do is go and find what delta is, which is your b squared minus 4ac. Now, for us to be able to do that, we need to be able to bring this equation to standard form. So let us start with what's given. Okay, on the left, I've got x plus m into x plus n. I'm going to use FOIL. First term, x squared. Then we're going to go to the inside and the outside, which is plus mx plus nx. And then your last term would be plus m times n, which is nm or mn, which is equal to k squared. And I'm going to bring the k squared onto my left-hand side and equate that to 0. So you'll notice my first term is x squared. Let's simplify that. We have two terms in terms of x. So we plot a common factor, x into m plus n. And then we have a term without an x. So we know that the number in front of x squared or next to x squared is a, and in this case a is going to be 1. The number next to x represents b. It means our b is m plus n. And the number without x is our constant. So we're now going to go and find out what is delta. Remember equation delta, which is equal to b squared minus 4ac. So now we're going to put our a in there. Remember, sorry, b squared minus 4ac. b is m plus n all squared minus 4. A we said was 1. See that on the top. And c is what we have here, which is mn minus k squared. So that's what we have at this stage. So now we can actually go and try and simplify this to see what is actually happening here. M plus n all squared is m squared plus the middle term, and double that will give me 2mn plus n squared. And then I'm going to use distributive law and take the minus 4 in, giving me a minus 4n plus 4k squared. And now we're looking for like terms. And you'll notice that we have m squared plus 2mn plus n squared minus 4mn. So we have our two like terms there that we're going to rewrite. M squared 2mn minus 4mn would give you a negative 2mn plus n squared plus 4k squared. So we know the first three form a trinomial, and that would give me m minus n all squared plus 4k squared. Now, if you read the question, I think if we get to that step, we could get 3 marks. But the question says show, which means we are trying to prove. I just want to change my color. So when a question says show, it means prove. We want to show that what we have here is actually greater, it's positive, it's greater than equal to 0. Now, we know from this that m minus n squared has to be positive. You square anything in maths, it can either give you 0 or a positive. So our conclusion is m minus n all squared will always be greater than equal to 0. And we also know 4 is a perfect squared, which means 4 is positive, and we're multiplying it by k squared. We're multiplying it by a square number, which will also be greater than 0. So 4k squared is also greater than equal to 0. Therefore, it means this whole thing that we have found is greater than equal to 0. So we can say, therefore, m minus n all squared plus 4k squared is greater than equal to 0, and therefore the roots are real. And the roots are real because delta is greater than equal to 0. Thank you.